Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Apache Qpid is an open-source messaging platform developed by the Apache Software Foundation. It implements the Advanced Message Queuing Protocol, or AMP, which ensures interoperability and standardization across messaging systems. Qpid is designed for enterprise-grade applications that require high availability, scalability, and secure communication. It supports both point-to-point and publish-subscribe messaging models, making it versatile for various architectural needs. Qpid stands out because it adheres to the AMP standard, ensuring compatibility with other AMP-compliant systems. It supports multiple platforms and languages, including Java, C++, Python, and .NET. Its architecture allows for horizontal scaling and fault tolerance through clustering. Security is also a priority, with built-in support for TLS encryption and SSL authentication. Qpid is composed of several core components. The Qpid broker is the central message router and store. Qpid clients allow applications to send and receive messages using various programming languages. Management tools like the Web Console and JMX interface help monitor and configure the system. Plugins and extensions enable additional functionality such as custom routing or monitoring. Qpid supports multiple messaging patterns. Point-to-point ensures messages are consumed by a single receiver. Publish-subscribe allows broadcasting to multiple subscribers. Request-reply enables synchronous-like communication. Messages are routed using exchanges, which apply rules to direct messages to appropriate queues or topics. AMP, or Advanced Message Queuing Protocol, is an open standard that defines how messages should be routed and delivered. It ensures interoperability between different messaging systems. AMP specifies key concepts like exchanges, queues, and bindings. This standard is used by Qpid, RabbitMQ, and cloud services like Azure Service Bus. The Qpid broker is modular, allowing developers to extend functionality with plugins. It supports clustering for high availability and load distribution. The broker manages exchanges, queues, and bindings. It also handles message persistence and transactional guarantees, ensuring data integrity even in failure scenarios. Exchanges in Qpid route messages based on rules. Direct exchanges use exact matches, topic exchanges use pattern matching, fanout sends to all bound queues, and headers exchanges match message attributes. Queues are bound to exchanges using routing keys, enabling flexible message routing based on application logic. Queues in Qpid store messages until they are consumed. They support both durable and transient modes. Durable queues persist messages to disk, ensuring they survive broker restarts. Consumers acknowledge receipt, ensuring reliable delivery. Queues can also prioritize messages and set time-to-live values for expiration. Qpid provides robust security features. TLS encryption secures data in transit. SSL authentication supports various mechanisms like plain, anonymous, and external. Access control lists define who can perform actions like publishing or consuming. Certificate-based authentication adds an extra layer of trust for enterprise environments. Qpid offers client libraries for multiple platforms. The Java client supports JMS, the C++ client uses Proton for AMP 1.0, and Python has its own client library. These libraries abstract the complexity of the protocol, allowing developers to focus on application logic rather than messaging plumbing. Managing Qpid is made easy with a suite of tools. The web-based console provides a GUI for configuration and monitoring. JMX allows integration with enterprise monitoring systems. Command line tools offer scripting capabilities. Together, these tools provide visibility into broker health, queue depths, and message throughput. Qpid supports clustering for high availability. Clusters can be configured in active-passive mode with shared storage or message replication. Failover is automatic, minimizing downtime. Load balancing can distribute traffic across cluster nodes, improving performance and resilience. To optimize Qpid performance, consider trade-offs between memory and disk persistence. Batching messages and tuning prefetch settings can reduce overhead. Properly configuring connections and sessions avoids bottlenecks. Monitoring throughput helps identify tuning opportunities and capacity needs. Qpid supports multiple acknowledgement modes. Auto acknowledges messages automatically, improving speed but risking loss. Client mode gives control to the application, enhancing reliability. Dupes OK allows duplicates for better performance. Choosing the right mode depends on your application's tolerance for message loss versus performance needs. Qpid supports transactions to ensure message reliability. Local transactions group operations within a session. Distributed transactions, using XA protocols, span multiple resources. This ensures data consistency across systems, even in the face of failures. Transactions are essential for applications where message loss is unacceptable. Qpid allows setting time-to-live TTL on messages to prevent indefinite queuing. TTL can be set per message or at the queue level. Expired messages are automatically removed, reducing storage overhead and ensuring queues don't become clogged with stale data. This is especially useful in high-volume systems. Priority queues in Qpid allow messages to be delivered based on priority levels. Higher priority messages are consumed before lower ones. Priority ranges are configurable, allowing fine-grained control. This is especially useful in real-time systems where certain messages must be processed ahead of others. While both Qpid and RabbitMQ implement AMP, Qpid uses the newer AMP 1.0 standard, offering better interoperability. RabbitMQ uses AMP 0-9-1 and has a broader plugin ecosystem. Qpid's modular broker allows for custom extensions. The choice depends on your protocol needs and ecosystem preferences. Qpid is designed for traditional message queuing with point-to-point and pub-sub models. Kafka focuses on event streaming with high-throughput log-based storage. Qpid consumers pull messages, while Kafka pushes messages with configurable retention. Choose based on whether you need queuing or streaming semantics. In financial services, Qpid is used for real-time trade processing where low latency and reliability are critical. Secure message routing ensures sensitive data is protected. High availability clusters prevent downtime. Qpid also supports audit trails for compliance, making it ideal for regulated environments. IoT platforms use Qpid for scalable device-to-cloud messaging. Qpid's lightweight clients support constrained devices. Its routing capabilities handle millions of messages. Integration with analytics systems allows real-time insights. Qpid ensures that critical IoT data is delivered reliably and securely. E-commerce systems use Qpid for order and inventory updates. It decouples microservices, enabling independent scaling. Event-driven architecture ensures real-time updates. Qpid scales to handle peak loads during sales events, ensuring a smooth customer experience without system downtime. Installing Qpid Broker is straightforward. Download the latest release from the Apache Qpid website. Extract the archive and configure settings like ports and security. Start the broker service using provided scripts. Verify the installation using the web console or command line tools to ensure everything is running correctly. Configuring exchanges and queues in Qpid involves defining exchange types like direct or topic. Queues are created with settings like durability and TTL. Bindings connect queues to exchanges using routing keys. Testing with sample messages ensures the configuration works as expected and routes messages correctly. Writing a Qpid client in Java starts with adding the Qpid JMS dependency to your project. Create a connection factory with broker details. Use sessions and producers to send messages and consumers to receive them. Always handle exceptions and close resources properly to prevent memory leaks and ensure clean shutdown. The Qpid Web Console provides a browser-based interface for monitoring. Access it via a web browser and log in with configured credentials. View real-time broker statistics, inspect queue depths, and exchange configurations. Monitor message flow to identify bottlenecks and ensure system health. Common Qpid issues include connection timeouts, often due to network or firewall settings. Authentication failures may stem from misconfigured SSL or TLS. Queue full errors indicate consumers are not keeping up. Message routing issues can be traced to incorrect bindings or exchange configurations. Logs and management tools help diagnose these problems. To tune Qpid performance, adjust prefetch settings to balance consumer load. Use batching to reduce network overhead for high-throughput scenarios. Optimize persistence settings based on durability needs. Monitor CPU, memory, and disk usage to identify bottlenecks and ensure optimal resource allocation. Security best practices for Qpid include enabling TLS encryption for all connections. Use strong authentication mechanisms like SSL with certificates. Restrict access using access control lists to limit who can publish or consume. Regularly update Qpid to the latest version to patch vulnerabilities and improve security. Scaling Qpid involves adding nodes to a cluster for increased capacity. Configure shared storage or replication for data consistency. Balance load by distributing client connections across nodes. Monitor cluster health using management tools to ensure all nodes are functioning and traffic is evenly distributed. Qpid integrates seamlessly with microservices by decoupling communication through queues. Use publish-subscribe for event-driven updates. Handle service failures with retry logic and dead-letter queues. Monitor message backlogs to detect slow consumers and prevent system degradation. Qpid's plugin architecture allows extending functionality. Custom exchange types enable unique routing logic. Monitoring extensions provide deeper insights. Authentication plugins support new protocols. Message transformation plugins can modify content on the fly, adding flexibility to your messaging workflows. Logging and auditing in Qpid involve configuring detailed logs for troubleshooting. Enable audit trails to track message flows and user actions. Integrate with SIEM tools for centralized monitoring. Regularly monitor logs for anomalies that could indicate security issues or performance problems. Backup and disaster recovery for Qpid involve regular broker configuration backups. Replicate cluster data to secondary sites. Test failover scenarios to ensure quick recovery. Document and regularly update recovery procedures to minimize downtime during outages. The future of Apache Qpid includes ongoing improvements to AMP support and performance. Cloud-native integrations will expand its use in modern architectures. Enhanced management tools will simplify operations. As an open-source project, its development is community-driven, ensuring continued innovation and support. In summary, Apache Qpid is a robust messaging platform built on the AMP standard. It supports queues, topics, and advanced routing for flexible communication. It's ideal for enterprise and cloud environments requiring high availability and security. With rich features for monitoring, scaling, and management, Qpid is a strong choice for modern messaging needs. Thanks for watching this deep dive into Apache Qpid. If you found this tutorial helpful, please like and subscribe for more technical content. Share your Qpid use cases or questions in the comments below. Check out the related videos for more messaging and integration topics. Join our tech community to stay updated on the latest developments. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.